All right, good morning, everybody, to this Tuesday, which I understand is scheduled to be an open Q&A session. But from yesterday, if you remember, we have a little bit left to do, and unfortunately, we have to dip into this session. But hopefully, it doesn't take the whole session, and even if it does, it's important stuff. It's necessary to get done. As always, can someone please let me know in the chat that you can both see and hear me, and then we can get started. All
Loud and
right,
clear.
perfect. Now, if you remember, we did some problems. I can't find my cursor. There it is. We did some exercises, not problems, exercises. In 313, we looked at uh, efficient ways of adding a lot of numbers with a clear pattern in them. 1, 2, 3, 4, 5, all the way to 100. That was this one. We had our strategy. Then we repeated that strategy for exercise 314, the first one, 246, and so on. And the second one, where it didn't start at maybe an obvious starting point, but still had a clear pattern. And every time our strategy of doubling up the sum in a clever way worked, and it just takes some practice to be sure about how many of those terms there are sometimes. Sometimes it's a little less obvious. You just have to think carefully. Now we'll go on to number 3, where we have 1, 2, 3, and so on, so an obvious sequence to start with, but we don't specify the end number. It might be 100, it might be 7. We leave it open to be represented by n, and it could be anything. So I want to use the same strategy without specifically knowing the end number to see if I can come up with a formula for how to sidestep all of this stuff that we did here. And in order to come up with a formula, I can't have a specific number there. I need to leave it open with a symbol to see what happens to that symbol as we follow this argument. So it might be a little uh, more confusing not seeing a number. It does upset some people, but that is what we need to do in order to. Sorry, I'm just going to make it a little more space in order to see what a formula could look like. So dot dot dot, we're going to end with the last number. Then our strategy is the same. We're going to double up. So now we're flipping everything, and the last one is written first. The first one is written last. The number right before n is going to be 1 less than n, and we'll represent that by an n minus 1. I'll put brackets around it to remember that represents one thing in my sequence. One step further back is n minus 1 minus 1, so n minus 2. And that now goes all the way down until I hit 1. Same sequence, just backwards. Then my strategy was to pair them up. The first ones in line will be 1 plus whatever n's value is, will be n plus 1. Then I pair up the next couple. 2 plus n minus 1 will also be n plus 1. The next pair also be n plus 1. Next pair also be n plus 1. And you saw that in the case of 100, for n, our pair was 101, 100 plus 1. But now we don't know if n is equal to 100. It could be other numbers. Regardless, it'll be that number plus 1. But the downside is that we doubled up our sum, right? That's not really that big a deal. We just have to correct it at the end. So now my question is again, how many of these n plus 1s are there? That's a question, which means you answer it. What do you think? How many of these n plus 1s are there?
Wouldn't we not know because we don't know the
No, we don't know the
length?
number, but we do know the amount would correspond to whatever the value of n is. Like if we stopped at 100, there were 100 of these pairs, these terms. If we were to stop at 200, we just keep going, and we did the same thing, there would be 200 of them. So how many there are is represented by whatever n is. So we could say casually, there are n of them, assuming we will one day have a specific number. Right? Because this is the first one, this is the second one, third one, so and so and so and so and so and so. So the first numbers count those exactly, which is why we start with this sequence. So it's nice and convenient as it can be. So there are n of them. Just like in the first example, when we went to 100, our pair value was 101. There were 100 of them because 1, 2, 3, 4, 5, 6, all the way to 100 at the top. We then realized that was repeated addition. However many of these repeated numbers will be the multiplication. So now we have, let's see over here, n times n plus 1. And that equals double our sum. So try to see the similarities between the case where n was equal to 100. We just want to leave it open because we don't want to be limited to a specific number and a specific sequence. That's the whole point of finding a formula. And then our correction at the end to find the actual sum or the calculation behind it will be then just divided by 2. So now I have a formula, which means that if I want to use the formula on, let's say, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, because I'm too lazy to count them, to add them one by one, anything that starts with a 1 goes up by 1, 1, 2, 3, 4, 5, and so on, and ends wherever that will be the value of n. And my formula gives me the answer immediately. It'll be 7 times 8 over 2, which is 28, which we found manually anyway. But now if I go 1 plus 2 plus 3 all the way to, let's go 200, I don't know. I do have a strategy. It doesn't take that long. I oops, I could go through the motions of doing this every single time. It's not that long. It's totally doable. I just have another option by way of the formula, in that I can now say it is the end number times the end number plus 1 over 2. Let's see what that is. MathBot says 200 times 201 divided by 2 is something. It is 20,000. Really? Wow. 100. Didn't know that. So a formula has pros and cons. The pro of the formula, of course, it's super fast. The con, I don't really understand what I'm doing, right? Because the formula hides all the detail
Oh, you
that
just cut
is
out.
our method. Sorry, continue.
Oh, sorry, just audio just cut out.
No, it's fine. Say what you wanted to say.
No, no, your audio cut out, but I think it's back. Never mind.
Oh, okay. Oh, no, no. Definitely say that as soon as that happens. What did I say? Pros and cons. The pro of the formula, super fast, super easy. You just plug in the end number and you're good to go. The a con first is that there's no understanding in using a formula, right? You just plug stuff in. A monkey can do that if he's well trained. And another downside to the formula is it was very specific to this sequence. This was the sequence. Having to start at 1 and having to go up by 1 every time. It had to be the sequence 1, 2, 3, 4, 5, 6, 7, and the thing that is left open is the number I end with. And of course, there are many other sequences, right? This one, it doesn't start at 1. It doesn't even jump by 1. So I'm kind of screwed. This one, it doesn't start at 1, but it does jump by 1. So it's closer, but it's not exactly this sequence. So the downside is it's a formula very specific to this sequence. And if I don't have this exact kind of sequence of numbers, then I either can't use the formula or I have to see and change things to see how I can use the formula. So in that sense, it confuses people a little bit. I will say right now, you don't need the formula. Our strategy is always going to work for us. The formula is just a little bit faster if the sequence happens to look just right. Okay. So whenever I have starting with 1, going up by 1, the formula is directly applicable and it gets me the answer right away. Options for what I can do, actually I'm going to do this one first. Options for what I can do if the sequence doesn't fit perfectly to what the formula wants. I can still use the formula usually. Stop that stupid line. Okay, so let's use the formula as another option. It's not a must. It's an option you might never want to use, and that's okay. So let me just rewrite here what I had. This is what was given. I know I can't just plug 40 into the formula because I don't start at 1. It's not the exact same sequence. Before I can use a formula, I need to see the sequence perfectly. And this one has some stuff missing in the beginning. So why don't I just add those things? I'm going to add everything up to 19 and then, of course, the numbers that I originally had. So I added these ones in the bracket. Now I've changed the value here, right? If I add these numbers together, my answer is not the same as the original problem. It's not the same. I'm looking for S, and that's not the same now. But I can make it the same by just taking the bracket away again, essentially being left with the squiggly numbers. So if I take away everything I add, immediately take it away again, I've really added nothing. Is everyone okay with that? As okay as you can be so early in the morning. So I understand that I've added things I shouldn't, so I immediately take them away. So now I'm left with the underlined section again. But if I now merge the first bracket with my middle numbers and see 1 plus 2 plus 3 all the way, it doesn't make it skip any number, all the way to 40. Whoops, where's my plus? All the way to 40, I'll make a square bracket. And of course, the part that I had to take away is still there. Didn't do much to them. But now, if I look at the square bracket, That fits my formula perfectly. It starts at 1, it goes up by 1, it ends in 40. So that's 40 times 41 over 2. If I look at the round bracket section, that's also perfect for the formula. It starts at 1, it goes up by 1, happens to end at 19. So the formula says it's 19 times 19 plus 1 over 2. And there we go. Now we can calculate it. 40 times 41 divided by 2 minus 19 times 20 divided by 2. MathBot says, what do you say, MathBot? 630. Done. Different approach. You might like it, you might not like it. Know your options, and then you are better equipped to handle a variety of questions, whether you use all the options available or not. You might never want to use this, but at least you've seen the options and then you can refine your strategy by picking one, or maybe you like both. Doesn't matter. I can always do either one of these. Well, adjusting the formula can sometimes be a little tricky, so it is definitely a little more advanced, I would say. You can always do the basic, write them, flip them around, add them up in pairs, count how many there are, boom, you're done. You can always do that. There's no harm in doing that. Let's see the third one that we have. I can't apply the formula directly because multiple reasons. It doesn't start at 1 and I'm not jumping by 1. So it fails on both requirements. But maybe I can still do it. Again, optional. Like it, don't like it. There's no harm. There's no downside here. What was it? 2, 4, 6, dot, 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 all the way to, why do I not remember this? 100. That is what I'm ultimately trying to figure out. Now, clearly, this does not look right in any way. I'm going to factor out a 2. And then I will have left in the bracket 1 plus 2 plus 3 plus so on, all the way to 50. Because when I multiply the 2 back in, I get 2, I get 4, I get 3, I get everything all the way to 100. But because of what the sequence looked like, I had to do something else. This now in the bracket is perfectly set up for the formula. And it is 50 times 51 over 2. I still have this 2, so it's 2 times 50 times 51 over 2, which is get rid of this line, stupid line, 2,550. You might like this option, you might not like this option. There is no downside. Just know that when you use the formula, you have to use the formula where it's appropriate. And it's only appropriate if I start at 1, I go up by 1. If my original sequence doesn't look like that, I need to tweak it and do stuff to see where the formula can be applied. And that can sometimes be a little confusing for some. It's an option. Again, can always go and do my basic strategy, write them, flip them, add them in pairs, count how many there are, and you're almost done. Those will always work. You can choose. It doesn't matter. Know your options, and then you are better off. Even if your strategy is to avoid one option completely, that's still being better off. All right. Thoughts on this lovely question? And if you think for a second, like, no, this isn't important. I'll never see this in the test. You are very wrong. It'll definitely be in a test. but you'll always have the choice to do whatever option you want. I'm never going to force you to use a formula. I'm never going to force you to use this strategy. You do whatever you want as long as you can accurately find the answer and explain how you did it. All right. Where are we now? We missed, on purpose, exercise 3.4. So let's do it if there aren't any questions. Maybe you don't know what to ask. 16 people in a round robin tournament played every person once. How many games were played? Now, a strategy that I have mentioned before that comes up in this one as well, in my opinion, is 16 people. It might be it might be more. The question just happens to ask 16. But a number that is in the question might be too big for me to wrap my head around, or too big for me to draw a picture for, or something. It's just a slightly uncomfortable situation. What I can do very often is make the problem smaller. It's not asking us a simpler question first. It's the same question, but just let's take the small numbers. Let's take convenient numbers. Let's take just, whoops, that was supposed to be a J. Take just 6 people. Because 6 people I can arrange very nicely, whereas 16 I cannot do it in any nice, clean way. So I'm going to call this person 1, person 2, person 3, person 4, person 5, and Bob. No, I'm just kidding. I guess we'll call them person 6. Not very original, but still. Okay? I'm doing the exact same thing. Now only 6 people are playing in a round robin tournament. Everyone plays everyone once. How many games were played? So I'm not changing the question. I'm just making my life easier to try and figure out a strategy. It's not the same as asking different questions on the way. It's slightly different. Okay. So now I'm going to make a little table here to keep track of the games played by person 1. I'm going to use some color because it is nice. Ooh, that is a nice color. I like that. Person 1 is going to play against person 2, person 3, person 4, person 5, person 6. That will be 1, 2, 3, 4, 5 games. 5 games. Next up, person 2. Person 2, you're up. Now, I don't want to count the game that person 1 and 2 played again. I just want to count how many different games were played here. So we'll say here maybe different games. I've already counted this purple line. So when I look at person 2, I don't want to count that again. Then my number won't be accurate. My number is going to be way too much if I count games more than once. So person 2, the new different games that I count will only be these blue ones. And that'll be 4. Then when I look at person 3, it's going to be new games that I haven't counted yet. 1, 2, 3. Person 4 will contribute new games 2. Person 5 will contribute 1 new game that I haven't considered yet. And person 6 will contribute none because all their games are already counted. All right. Hopefully everyone understands what's happening because no one is saying a thing. This is the continuation. Is it Monday still? I thought it was Tuesday. Oh.
No, so far so good.
Okay. Now, of course, we made it simpler. So yes, the answer certainly is just adding these numbers together that we can do because there aren't many of them and they're so small. 1 is 3 is 6, 10, 15. So 15 is our answer. But I want to do it in a way that helps me for my actual problem that is bigger. This comes from 5 plus 4 plus 3 plus 2 plus 1 plus 0. Okay, so now I can see that what happens if I make it bigger. So now let's take our 16 people. Let's make it red so I can see the changes. Ooh, that's a nice red. 16 people. My strategy is going to be the same, except I'm going to go all the way around until I hit person 16. And there's going to be a lot more people in my diagram. And I just don't want to see them all. I don't need to see them all. Person 1 will now play 15 games. Oops, that was supposed to be a 15. Because they're playing against person 2, 3, 4, 5, 6, all the 16. One less than the number of people. Again, when I look at person 2, I'm not going to count back. I already considered that game. So there will be 14 and 13 and 12. And now I need to make some dots. And the last person, which will now be person 16, will still contribute 0 games because I've already considered all their games. So the argument, the extension to more people isn't that big of a jump. Actually, it's a very small little step. It's a hop, maybe. So now, okay, my answer isn't 15 anymore, but I can find my answer by adding up those numbers. And my answer, let's do it like this, will be 15 plus 14 plus 13 plus all the way down to 1, 0. That'll be my answer. So now I just have to, yeah, okay, it's not that bad. I can do it one by one, but surely I've learned something and I can do this more efficiently. Stupid. I press the button. It doesn't want to give me the hand. There we go. So now this, I can rewrite. Well, the 0 doesn't matter. It doesn't contribute anything. And then I can swap them around. 1 plus 2 plus 3 all the way to 15. And that fits the formula perfectly. I have a formula for this. It's 15 times 16 over 2. Wow, look at that. 15 times 16 over 2. And there are 120. So I could say there are 120 different games played. Done. But potentially, what made it easier for me is to just get a diagram, of course, but in my diagram, I can't do too much. Their number might be a little bit inconvenient for me. So I'm not changing the question. I'm just taking numbers that are easier for me to work with and seeing how they suggest things can be extended to the bigger situation. So I have many options, and these things do not come naturally. I think I gave an example of a grade 4 question I saw recently. It's not natural. It's not the first inclination people have to, if the numbers that the problem give me are too big or too uncomfortable, change them. Make them easy numbers. Make them numbers that I feel more confident about, that are easier to work with. I didn't change the question. And even in doing that, I can better understand the question and very often see how I can answer the original question. It's a very nice strategy that apparently needs to be trained and learned, and it doesn't come naturally. Okay, while I'm looking for the one we missed, whoa, that was too much. Feel free to comment or ask your question.
I have a question about it.
Yes,
I'm just wondering, how do we automatically know that it's 15 times 16 divided by 2?
because that's my formula. My formula says if I have numbers being added together and those numbers in sequence are 1, 2, 3, 4, 5, 6 up to an end point, which we represent with an n in the formula gives me the answer to that sum. It is the
So
end
that's
number times the n number plus 1 over 2. So
okay, so that formula we can just use into any equation if all the numbers um, are going one by one.
it has to
Is
start
that
at 1, it has to increase by 1.
okay?
And ours luckily has those two properties. And I mean, the formula is not uh, completely useless in other cases. I might just have to sort of work with it a little bit. Like if
Okay.
it doesn't start at 1 and it doesn't jump by 1, or I lose either one of those properties, I'm going to have to tweak some stuff to see the formula. It might still be in the background. It's just not immediately usable. And what I do might change, which is what people don't like. But if it's exactly ready for the formula, why not just use it? Why at this stage, yes, you totally could write the 1 to 15, flip them around, add them up in pairs, count how many there are. You'll get to the same thing. The formula is just there for convenience, but I do need to know when I can use it and when I can't.
Okay.
And
Thank you.
it's there as an option. You don't ever need it at this level. But it's good to see uh, formulas. It's good to see their pros and cons because when you start going drifting towards high school, I'll say, then people are obsessed with formulas. There should be a formula for everything. They just want to plug it in. They don't want to think anymore. It's dangerous. It's not a good idea. So being aware of formulas and their role, pros and cons, it's good early on. But of course, we're not gonna have many of them. All right. We have one more, which is a completely different question. 315 and we will be done. 8 marbles look alike, but one is slightly heavier than the others. Using a balance scale, explain how you can determine the heavier one in exactly 3 weighings, 2 weighings, and so on. So let me just clarify this question because there might be people who don't even know what a balance scale is anymore. Where would you use one? So we have, what's this number? 18? Yeah, 15. Oh no. Why am I still pink? Example 315. I have my 8 marbles. They are identical. I have a balance scale, which is a little scale here with 2 little areas where I can place stuff, and then whichever side's heavier, it'll tip to that side. Okay? And if they're perfectly the same weight, it'll stay level. Okay. Now I can use this. Let's say here number 1. I can use the scale, what does it say? 3 times. I can use it 3 times only. And after I'm done using it, I have to have a single marble in my hand, and that has to be the heavy one. And they look identical. But I want to be sure that everyone understands the question first. How can I? Now, we won't explain it in a lot of words because it's tedious, and I'm here to do it. You can watch the video so you always have the explanation whenever you want. So we won't write too much, but we'll just do some diagrams to keep track of what we're saying. First of all, can I do it in three uses of the scale and then be left with confidence I have the heavy marble in my hand? Because the weight is slight. I can't feel one is super heavy, right? They're just slightly more heavy. So the scale will tip to one side as soon as the heavy one's there, but I can't feel it and guess. Any ideas what we can do?
Could you divide the marbles in half and
So
put
let's
half in
divide them
one
in half.
side?
Absolutely. Split them in two. We put either group of four on a side, and now one side is going to tip over. Let's suppose this side is heavier. One of them is going to be, right? Doesn't matter which side. Let's just take that side as the heavier side. So now we know that the heavy marble is among those four. What can we do now? So that's one use.
Do the same thing
Just do it
and
again.
split them in.
Maybe we get these two are heavier. It doesn't matter. So then I have used it again. Now I'm down to two marbles, and of course, put one on either side, and maybe that one, and I'm done. Three uses. I found the heavier marble. Okay. Really not a complicated strategy, I hope. Most people would come up with that. Because I have eight, it's very nice and convenient. However, next up they ask, can it be done in just two uses of the scale? So let me draw my marbles here. One, two, three, four, five, six, seven, eight. They're identical. Can I do it by using the scale only twice? That is the question. And I have no shame in admitting that if I didn't know the answer beforehand, oof, that's not easy. But it's one of those things that once you see it, then it's going to show you what it wants to show you, and now having seen it, you move on with your life. Not a trick question, but something very specific that it's teaching you, and then you know the answer. Can it be done? Can it be done? Well, if I do it, split them into four and four, it's going to require three uses. So that's not going to be the strategy. So the problem is, what else can I possibly do? And here is where I am so quick to think, I guess, inside the box. I'm so quick to limit myself in my thinking that I assume that all the marbles have to be put on the scale at all times, whatever marbles I have left. And nowhere did it ever say I have to put all the marbles on the scale. I can use the scale however I want. Sure, if I have a lot of opportunities to weigh and use the scale, I'll put a lot of stuff on, sure. But no one said I have to. I don't have to put on all of the marbles that I see. What if I just leave two out? They're not thrown away. I need to think about them. And then from these six that are left, I'll split them three and three and put them on the scale. What could happen? I have two options. I have, or two cases. I have case one and case two. Two different things could happen when I put three and three on the scale. What's one thing that could happen to the scale?
They could all weigh the same.
Could all be the same. So the scale is balanced. That wasn't fruitless. That tells me something. What does that tell me about where the heavy marble is?
And the two you left out.
The heavy marble is among the two that I left out. Let's make them red. Let's put them over there so we can keep track of them. So what I have left is the two heavy marbles that I left out. It has to be among those. Well, now I have one use left. Split them 1, 1. Done. But what else could happen when I weigh the 3 and 3?
One side is heavier.
One side's heavier. So let's say here one side's heavier. So then I'm left with uh, 3 marbles, whichever side was the heavier marble, whichever side was the heavier group. I have only one opportunity left to use the scale. What do I do? I have an odd number of marbles left. What can I do?
You can weigh 2 of the 3.
Leave one again. Leave it out. Oops, that was an E. Oof, that was ugly. Leave one out. I don't know which one. The one on the end. I don't know. And then I'll weigh those two, split them up. Again, 2 cases. Case 1 is it's balanced. That means, let's make it a blue one. Let's make this guy blue. That means I found the heavy one. I found bluey. And I'm done. Or what else could happen is when I weigh them, I found one that's heavier, and I'm also left with the heavy marble, and I'm done. Now I know this explanation isn't very, it's not standalone in any way. I need to be there to explain it. But if we write a lot of words, then it just is so time consuming for us right now. The point is it can be done, but I'm so quick to think I have to put all the marbles on. No, no one said I have to put all the marbles on. Yes, that is a basic, straightforward strategy. But if I have an odd number of marbles or I'm limited in how I can use the scale, I need to be a little bit more creative in my strategy. Just hold some back, weigh the others. And regardless of what happens, I still get information that leads me to the heavy marble. So it's very interesting for me to see this. Like I can find it without ever weighing everything. That's weird. It's weird. But that's because I limit myself automatically in my thinking, and that could prevent me from solving problems. And it's only my own fault. All right. That wraps it up. We are done with chapter 3. Now it's up to you to see how many problems you want to do, what they can teach you. Some are going to be, I'll say it right now, some problems are going to be super straightforward. Don't overthink them. Let the problem be what it is. People make this more difficult by expecting problems to all be challenging. Some are going to be super easy. I can't say which one. That depends on you, really, and your experience. But let the problem have a strategy that it requires. If it's straightforward, then let it be straightforward. If it happens to be more involved, then adjust your strategy to take care of that complexity. Don't go in thinking it's going to be one thing when it's maybe another. You don't know. Just keep an open mind and see what we can learn from all these problems. They're all good. Really, all of them are, yeah, All of them are good. I don't love 311. I think it's a little too trial and error. It's a little too guess and check for my liking, but still, it's doable. Definitely focus on the containers. Super important. Chip and Dale I mentioned. Very, very nice. Um, yeah, they're all good. Where are adding of numbers questions? Yeah, there's some number questions there. Of course, you can make up many other examples where I add some numbers together, right? Uh, these are just a few, but definitely there should be enough problems for you to keep you busy. All right. Any comments? We pretty much took all the time. I suspected we would. Let me actually just check the schedule here real quick and see what we can do. Let's see, where are we now? We are Tuesday the 29th. Let's see, what is the next month? Oof, we have 1 month, 1 month, 1 day left this month. Then our quiz is next Monday. Next Monday. Now, in the interest of saving time, I wanted to put the quiz sort of after a weekend. I thought that would be a good idea to give you more time to study. But we can't take the rest of the week off. We have to sort of make progress with the next section, even though it's not on quiz one, get a little bit of a head start before the quiz actually happens. But there are some Q&A sessions, and then I put a Q&A session after the quiz in case you didn't really pay attention about chapter 5 because you were focused on the quiz. Just a little catch up before we now really get into the the heart of the second part. So the overlap is a little bit unfortunate, but there's really no way around it. Otherwise, we're going to run out of time. But if we do it this way, then in December, close to the end, we have a much better time to prepare for the final exam and just catch up if there's anything that's a little uh, shaky. So, pros and cons. So just be aware of the schedule, be aware of the options, be aware what's happening tomorrow. We are going to start with chapter 5, with the next part, even though that is not going to be on Monday's quiz. So it's a little bit of an overlap. Any thoughts or questions on what is coming up?
Um,
I was just wondering what the format of the quiz is like.
What do you mean?
Is it multiple choice or
No,
is it
no multiple choice.
no multiple choice?
Especially because the test is open book, right? Multiple choice would be way too easy. And
Right.
challenge yourself. You came all this way. You paid good money. You need a good experience. Multiple choice is too easy. It's already going to
And then,
be, I think, too easy with all the resources available to you uh, during the test. But that's okay. You can use anything you want as long as it's not a person. So you can use the videos, you can use the book, you can use notes, you can do whatever you want to do, as long as you're not getting help from an actual person.
and then
Uh, yeah. So we'll have uh, it's an hour test, but you have an extra 30 minutes to scan your paper, email it back to me, and all the technical issues that might come up. So there should be more than enough time to do everything. Even open book is deceptive. people tend to think, myself included, like, oh, I could just go and look for the answer. But there might not be time to go and, let's just randomly say, there's a Karuji puzzle. There's not really time to now go and say, oh, let's go and learn how does Karuji work again? Let's go watch the
Yeah.
video and figure it out. There's no time for that. So you do have the resources, but you don't have that much. You don't have time to now suddenly learn a topic. You can quickly go and double check something, but open book is deceptive. It's a false sense of security that I really have to be careful of. You still need to know what's going on, but you have that security blanket, sort of
Okay.
that safety net that you can go check something. Do I
Mm-hmm.
remember this right? So it's tricky. You have to approach it right. But I think there's more than enough time for
Okay. And
the test.
how many questions were there?
It depends. It changes. Like I'm just thinking of Karuji randomly. If I were to ask a little 3 by 3 Karuji, I'd maybe ask two of them. But if there's
Right.
a 4 by 4 Karuji, I'll only do one because it's going to take longer. So it really depends on the question. Uh,
Okay.
I can't really say. I can only say that there an hour is more than enough time if you know what's going on.
Okay.
So time shouldn't be an issue. Uh, then I will say, in case not many people are here, but for those that are, if you have an arrangement with the college that you get extra time, just let me know when you send me your answer. Like, oh, I actually got this much time, just so you know, so that I'm aware because I can't remember who does what. But if it's just standard time, you just have to make sure that you send me the email, or let's say it this way. You have to make sure that I receive the email before the hour and a half. Now, if you are in the 8:30 section, you start at 8:30 and you can go until 10. If you are in the 10:30 section, then your test starts 10:30 and you go until 12 because some people might only have their registered sections that time available. So whatever your registered time is, you'll see here in the schedule. It says 8:30 or 10:30, whichever time applies to you. So it's a little different. Uh,
I just have a question about that. Later in October, we have another quiz, and I have like a doctor's appointment at the same time as the quiz. Is there any chance that I could go earlier or later, or do I have to
if
do the
you, the
10:30
only
one?
other times, if you happen to be, let's suppose you're registered in the 10:30, you can do the other one. But 8:30 and 10:30, those are the only times. There's
Okay.
no
Yeah.
makeup
No.
test. If that's a totally valid excuse though, right?
Yeah.
If you have some valid reason for missing the test, then and you can't reschedule things like that,
Yeah.
then we can give you an excuse so it doesn't penalize you in your overall grade, but there are no makeup tests outside of those times. Actually,
Okay. So
there
I
are
can
no
take
makeup
the
tests.
8:30 one if I'm busy at 10:30.
Yeah, so let's suppose you have an appointment at 10:30. You can take the 8:30. I mean, it's not
Okay.
the same test, but it's the same kind of test.
Okay. Content.
So that's fine, yeah.
Right. Thank you.
Yeah. Maybe just let me know that you did that so I don't get confused, but it shouldn't be a problem.
Okay.
All right. As the week goes, if you have any other questions, let me know. How do you know what time applies to you? Uh, you should know which section you're registered in. I like that question actually because it tells me that you don't care when the videos happen, you watch them anyway. But some people, there were two sections created by the college for some unknown reason. I don't want to go into that. Uh, so some people only have the 8:30 time slot available and they watch the videos on the other days. Some people only have the 10:30 and they registered for that section. So because they might only have those time slots available, the test has to be in their registered time slot. If you don't know which time applies to you and you don't care, pick a time and write in that time. If you want to get up early and get it done, do the 8:30. If you want to do the 10:30, I really don't care. It's just for those that need one or the other. If you don't care, I don't care. As long as you write at one of those times. Doesn't matter to me. But for some people, they have something else happening at the other time, so they need to be done and all kinds of things like that. So if you have to ask how do you know which time applies, then it doesn't apply. It doesn't matter. Any other questions? Again, it doesn't have to be right now. You can stop by during a Q&A session. I had one Sunday, 9 o'clock. No one showed up. I was so sad. I came all the way. I walked like 10 steps to my computer, traveled so far for a Q&A session on a Sunday morning. No one showed up. But maybe this Sunday, or maybe the one on Friday. Ask your questions, or send an email, or use the Discord channel. So many options. Use them all, whatever you need, but don't leave your questions unanswered. All right, I guess we will end it over at this stage until tomorrow. So I do feel sorry that we have to start the next part right away, but it's going to pay off in the end, where we're going to have a lot of nice review time for our final exam, which of course covers everything. But one thing at a time. Until tomorrow.